Hello everyone. Welcome to this session on Heron's formula. In this chapter, we will learn what is Heron's formula and learn how to apply the formula and its applications. And as we are very familiar with what is a triangle and different types of triangles in our previous classes. And we have also learned that area of a right angled triangle is found by using the formula half times the base times the height. But if we have an isosceles triangle or scalene triangle, how do we find the area? So before that, let us know the triangle application in our daily life. This triangle is seen in the structure of triangles are seen in our surroundings, in houses, in bridges. So we can see different types of triangular patterns in bridges or the water tanks in this manner. Let us take the example of a bridge to understand that the triangles are applied in the engineering field also. And the pattern of these triangle makes the bridges concrete and increases its lifespan. Now let us know what is the application of Heron's formula. So before we learn what is the application of Heron's formula, let us learn the Heron's formula first. So the Heron's formula is given by the great mathematician named as Heron or Hero. So we call it as Hero's formula or Heron's formula. And this formula is applicable to different types of triangles like scalene triangle, isosceles triangle, right isosceles triangle. So what is the formula? If we take a scalene triangle having the sides as A, B, C, first we should write the formula. We'll write S of S minus A, S minus B, S minus C. So what is this S? S is a semi-perimeter that is obtained by adding all the three sides and divided by 2. So this is the Heron's formula, which is given by Heron. Now what is its application? So the Heron's formula is used to find what is the cloth needed, that is a quantity of cloth needed to make this shape for the boat, or here the umbrella, and we'll see few more examples where the Heron's formula is applied in our daily life. For example, we have a pattern or a design in a stitching or umbrella or anywhere. So how do we apply? Where do we apply? So let us take one more example. So this is the application of Heron's formula, where if we want to find the cloth required to make this triangular patterns, we can't apply the right angle triangle formula, so we have to go for the Heron's formula. And if we have a quadrilateral where all the sides are given and a diagonal is given, only one diagonal is given, then Also, we can find the area of this quadrilateral using the Heron's formula. And how to calculate the Heron's formula? Using for the different triangles we will see. So we will take a situation that is equilateral triangle, which is having each side as a units. So what is the equilateral triangle formula? We know that it is root 3 by 4 a square. To find the area, we use this formula. So area of an equilateral triangle is given by this formula. But how did we get this formula? So we can apply the Heron's formula to get this. So we'll see how it is. So we know that Heron's formula is S of S minus A, S minus B, S minus C. Now if I want to find S first, that is A plus A plus A divided by 2, which is equal to 3A by 2. And now when we apply the formula, we get 3A by 2 times of again 3A by 2 minus A, 3A by 2 minus A, 3A by 2 minus A. So when we simplify this, what do we get? So for that, just let me erase this. Now we get A equals to under square root 3 by 2 times A into A by 2, A by 2 into A by 2. So with this we get under square root 3 by 16 A square into A square, or we can write A power 4. So which is, so 16 is a perfect square. So when it comes out of the root, it is 4 under root 3. A square comes out. So this is a formula which we use to find out the area of an equilateral triangle. So in the same manner, we can find a formula which we use to find the area of a isosceles triangle. In the same manner, we can find. We take the isosceles triangle as the sides, two sides as each side as A units and the unequal side as B, and apply in the Heron's formula and derive it. So let's see what is the Heron's formula for the isosceles triangle. We know that isosceles triangle, let us take any isosceles triangle. It can be two sides are A and the other side is B. And here let us calculate S first, which is A plus B by 2. So which is 2A plus B by 2 is the semi-perimeter. When I apply in the Heron's formula, so S into S minus A of S minus B of S minus C. We know this. Now accordingly, we substitute the S value 2A plus B by 2 into again 2A plus B by 2 minus A into 2A plus B by 2 minus A into 2A plus B by 2 minus B. So when we simplify this, we get under square root 2A plus B by 2 times of, when I take LCM for the first bracket term, we get 2A plus B minus 2A by 2. So here again we will get the same term, 2a plus b minus 2a by 2. And the third term is 2a plus b minus 2b by 2. Again, further simplification, we'll see what we will get. So on further simplification, under square root, 2a plus b by 2, the first one. And the bracket term after simplification, 2a plus 2a gets cancelled. Here also 2a plus 2a gets cancelled. So we'll be left with b by 2 into b by 2. So b by 2 into b by 2. And the third last bracket term is 2a minus b by 2. 2a minus b by 2. So as this is a square term, so when I take it out of the bracket, it is b by 2, 1b by 2 we get, and under the square root it is in the form of a plus b into a minus b. So I can write it as a square minus b square by 4. So if I bring this 4 out of the bracket, it will be b by 2 into 2, which is 4. So under square root, it is 4a square minus b square. So this is the formula which we use to find the area of a triangle, which is isosceles triangle. And we can derive this formula in this manner by applying the Heron's formula. Hope you have understood the derivation of these isosceles triangle formula from Heron's formula and also the equilateral formula. And we will be applying these formulae in different situations that are given in our exercise sums. Thank you.